Hello everyone, my name is Artun Gopal Krishnan from CKF and welcome to Java Jumpstart. Today we'll be going over primitive data types. Let's look at what I'll be covering over today. First, I'll give an introduction on the different data types. I'll explain what are they used for and what are some limitations. Next, I'll give you an overview of all the different types of data types in detail. Third, I'll compare each data type and explain when to use which one. And finally, I'll give a summary on the main points to take away, especially for this course. Let me give an introduction first. Data types store data, obviously, and they're very efficient at it. But there's a fixed size for each data type, which means the amount of memory allocated for storing these types is known as compile time. This predictability leads to more efficient memory storage and faster performance. There's no additional overhead in memory management. But one drawback is there's no inbuilt methods. And we'll go more over methods in later videos, but essentially, we cannot perform certain functions to data types. But they are easy to be compared with other data types. For example, if you have int a equals 1, int b equals 2, we could simply do a equals b, meaning we're checking if a equals b. If it is equal, it returns true, and if it doesn't, it returns false. Data types are immutable, meaning once a value has been assigned to a primitive variable, the actual data stored in the memory cannot be changed, only reassigned. For example, if you have x equals 5, the value 5 cannot be modified, only x can be assigned to a different value. Now, what are some uses of data types? They can store very basic but essential data such as numbers, letters, and more. For example, by letters, they could only store individual letters. What are some limitations? They cannot store complex data such as words and for specific purposes. For example, if we want to store the word hello, we won't be able to do that using one data type. We have to create multiple data types to store a word. Now let me give you an overview of each data type. First, let's talk about byte. Its memory size is 1, and it can store numbers from -128 to 127. It is very efficient when dealing with raw binary data, meaning it could store zeros and ones very efficiently. Its default value is 0, meaning if we don't set a byte value equal to a number, it'll automatically be assigned to 0. And here's how you set up a byte primitive data type. First, you say byte, the name of the variable, and give a number between these two values. If you give an incorrect input, a syntax error will be assigned. And here are some examples on how you do it. Byte x equals -128, byte y equals 127, and byte z, z will be assigned to 0 since that's the default value. Short, its memory size is 2 bytes. Can store numbers from -32,000 to 32,000. As you can see, for only 1 byte extra, you could store way more numbers. This is useful for legacy code. Legacy code is application source code that has reached or crossed an end of a support system, meaning when a code is at its end of the memory cycle, it uses short to store each individual numbers. Also, as same as byte, the default value is 0. The variable assigning is similar to byte also. First you say short, the name of the variable, and the correct number. And the way you assign short is also the same. And z will be equal to 0. Next is int, one of the most used primitive data types in Java. Its memory size is 4 bytes, and can store numbers from -2 to 2 billion. It is one of the most used and important one, since for only 4 bytes it can store a large variety of numbers. Its default value is 0. And also, you assign the same way as you do for byte and short. You say the int, the name, and then set it equal to number. And here's some examples. Z will also be set equal to 0. Next is long. Its memory size is 8 bytes. It can store numbers from -9 quintillion to 9 quintillion. It's commonly used for scientific data processing. For example, when storing for scientific data, we have large numbers and very, very small numbers. For example, if you want to calculate the size of an atom, numbers will have a lot of zeros. Its default value is 0, and you set up the same as the rest: long, the name, and the number. Next is float. Its memory size is 4 bytes. It can store up to 34-digit numbers. Its size is so large there's not even a name for the number. It's extremely optimal for saving memory. If you have noticed, long was only 8 bytes and float is 4 bytes, but float can store more numbers. And the reason is because in float, it only approximates a number after 16,000. After that value, it uses chunk approximation, meaning it's not, for example, if you want to assign a float value to 16 billion, it won't be exactly 16 billion, but a value close to it. And when we want to do incredibly precise calculations, we should not use float, since we want to have the numbers as exact as possible. People use float because you can store large numbers for only 4 bytes, and you assign it the same as any other number variable. Next is double, also one of the most used numbers, primitive data types in Java. Its memory size is 8 bytes, and it can store up to 308-digit numbers. And one of the key points of double is that it can store decimals. The other primitive data types cannot have decimals, or there will be an error. Only double can have a decimal, and its default value will not be 0, but 0.0. You do double the name and then a number. For example, double x, you could assign a decimal number for each one of them, and z will be assigned to 0.0. Next is char. It's 2 bytes and can store any individual letter, numbers, and symbols. Its default value is Unicode 0000. If you don't know what Unicode is a simple way of assigning a number value to a letter and symbols. For example, the number 1 will have a Unicode, and number z and the letter z will also have Unicode. An exclamation mark will also have Unicode. This Unicode does not have any specific letter or number. Simply is the default value, and it's essentially useless unless we want to set up a basic value for char. And char w will be set to Unicode 000. To assign char, it will be a bit different from the other numbers because we want to assign letters. Char and then the variable, and you'll set equal to the individual letter or number you want inside single quotation marks. This implies this is a char. Next is Boolean, also one of the most useful parts in primitive data types. Its memory size is generally 1 byte. And the reason it does not have a specific memory size because the true or false values can contain a huge number of different true or false values inside it. It's very useful for determining logical statements, inequalities, and conditional checks. We'll be going more over how each part of these works in future videos. Its default value is true. You can only store 2 values, true or false. You do boolean, the variable, and put in the value. Boolean z will be equal to true. Now, let's compare each of these primitive data types. Why can't I just use double for all the numbers? I thought of this question too first when I first started Java. One of the most essential parts of coding is to make your code as efficient as possible, and it'll also take up less memory. When we try to create large code, it'll take up a lot of memory space. So we use each individual numbers for each individual type of value we want to store. For example, if we only want to store numbers from 0 to 1, that means we'll use a byte because it takes the least amount of storage space. But if you want to store large numbers, then we have to use the larger ones. And we use double for decimal numbers. Why does float have less memory size but contains more numbers than long? I explained a bit of this before, but I'll give more deep explanation. Float uses chunk estimations, which rounds the numbers, and after 60 million, all values will be approximated. But sometimes the larger the value gets, the more disorganized the approximation will get, meaning the larger the value, the less accurate the number will be. Which values can I compare? By compare, I mean if you could set one value equal to another. You could do operations with any numerical primitive data types, but they cannot be set equal to their larger selves. For example, if we have a variable using byte, we cannot set it equal to a short, since the memory size for short is larger than the byte, and byte cannot handle the memory size for short. But if you want to set a short equal to a byte, that will be possible. This is because short has a larger memory size than byte. The same can be said for all these values. The larger the value gets, the less likely that you could set equal to other numbers. Now, here's some key takeaways from this presentation. Usage. Primitive data types are used to store numbers, letters, and expressions, such as true and false. There are different data types: byte, short, int, long, float, double, char, and boolean. These are the only data types in Java, and there's no other ones. The most used ones are int, double, and boolean. Int is used for whole numbers, and this is because int has a lower memory storage but can store a large variety of numbers. Doubles is very useful because it's the only primitive data type that can store decimals. Booleans are unique in primitive data type since it can store true or false values or expressions. Comparisons. Lower values cannot be set equal to higher values, meaning if a value has a higher memory storage, it cannot be set to one with a lower memory storage. And that's it for today. Please check out our previous videos and stay tuned for the next one. Thank you.